So next is we have what will be the expression of our position, velocity, and acceleration in cylindrical. Okay. Example sa ta. Example. Okay. Okay. So before we proceed to cylindrical, let's have an example. Okay. Example in spherical coordinates. Mm-hmm. Mm-hmm. Okay. Okay. Example in spherical coordinates, we have this a wheel of radius b. A wheel of radius b. And hindi na nakasulat na lang. A wheel of radius b na siya sa analytical analytics. Analytical mechanics. Okay. Ano to? E-books. E-books. Tapos, okay. Okay, this one. Say for example, this using the expression in terms of in spherical coordinates. Okay, so if we have a wheel of radius b and it is placed in a gimbal mount which is made to rotate as follows. Okay, so ang iyang figure is kani. Okay, so na ako'y wheel. So ang may tabo ani is nasa duha ka tuyok. Okay, na ako'y duha ka tuyok ani. As you can see in the figure, na ako'y wheel. The radius of this wheel is b and gibutang nim siya sa gimbal. Okay, nga this gimbal will also rotate. So there are two rotations here. This ang imong wheel which is ga rotate padulong dira with some angular speed of omega 1. Okay, and we assume that angular speed as constant. Also gatuyok ang imong wheel. Also ang gimbal pod is gatuyok pod siya with some angular speed of omega 2. Okay, so what will happen or what will be the motion of this wheel, okay, with radius b. So duha ka bukayang tuyok, no, na koy omega 1. Okay, omega 1 which is mo ni ang motion sa imong wheel, and at the same time your gimbal also is rotating with some angular speed of omega 2. Okay? So constant lang ang omega 1, constant po ang omega 2. Okay? Such a way that the axis of the wheel stays in a horizontal plane and the center of the wheel is motionless. Okay? So kani I think is motionless. Kani siya. Ang mutuyok lang again is kani, mutuyok na siya. And then your wheel is also rotating. So question is, in spherical coordinates, calculate the acceleration. Calculate the acceleration lang. Because once we know the velocity, sa'yo naman ang velocity, sa'yo lang ang velocity, sa'yo na po ang position. Okay? So, to calculate the acceleration, we know that acceleration has three terms in terms of radial, in terms of phi, and in terms of theta. But first, lantawon sa nato in this system, lantawon sa nato what is the position r, what is r here, okay, what is theta, and what is phi. Okay. In this case, your r is fixed. Your r is just the radius of the wheel. Okay. Your r is just the radius of the wheel. Your theta Si theta ani, take note, in spherical ha, in spherical, kung na ako spherical, sorry, not spherical. If I have spherical, okay, your, this is spherical, no? Okay, gani. Okay. Take note, si theta is measured from the z-axis. Okay, if this is your r, for example, then this is your theta, and your phi is measured from the positive x-axis. Okay, from the positive x-axis. So as you can see here, your theta is actually the angle nga imuhang makuha sa kaning pagtuyok sa imuhang wheel. So therefore, my theta here is equal to the angular speed omega 1 times time t. At some time t, makuha nimo ang angular displacement theta uh, based from the rotation of this wheel of radius b. Okay? And also, si phi, kay makuha nimo aning ga-rotate nga gimbal, tama? So, si phi is makuha nimo kaning ga-rotate nga gimbal. So, therefore, phi is some angular speed which is constant omega 2 times time t. Okay? So, this will be the coordinates of the system na koy r nga constant, wala man nag-change ang radius sa imong wheel, na koy theta which is dependent on the omega 1, okay, the angular speed of the wheel, and for phi is dependent on the angular speed of the gimbal, okay, of the gimbal. Okay, so we have this na nakoy r, nakoy theta, nakoy phi. We can actually solve for a because a is equal to, so itong a na to, taas man to, no? A. Taas man tong a. Taas siya. Okay, nakoy r double dot minus, okay, again, no need to memorize, okay? No need to memorize this. So, bisag taas siya, makaya rin po na nag-solve, no? As long as, what? As long as we know the theta, we know the r, and we know the phi, we can actually solve for the velocity, acceleration, and position of the system. So, in this case, sa kanina example, ang ipangita lang mo is acceleration. So, diretso na to sa acceleration. Okay? So, na ako 2 r dot theta dot plus r theta double dot minus r phi dot square sine theta cos theta e theta sine theta cos theta e theta plus in phi nakoy r phi double dot sine of theta plus 2r dot phi dot sine of theta plus, which is muna ito assignment, no? Kani? So, somewhat sayop gamay sa libro ni Grant Fowles. Okay? Sayop gamay sa libro ni Grant Fowles. Ang sayop is katong e theta, okay? E theta instead of e phi, ang nasulat niya is e phi, but the correct answer is e theta. Okay? Okay, so na mag-zero ani, right? Na mag-zero ani yung mga terms because r is constant, so therefore r dot is also equal to r double dot, which is equal to 0. Okay? And then theta dot is equal to omega 1, while theta double dot is equal to 0. For phi dot equals omega 2, but phi double dot is equal to 0. So therefore, na yung mga terms yung mag-0, this one 0, sa pala mag-0 ano eh. This one 0 po eh. Okay? And then this one is also equal to 0. So therefore, my acceleration is equal to minus r. So the acceleration now is equal to, first term is minus r, theta dot square, so that is equal to minus b omega 1 square. So na ko minus b omega 1 square minus b omega 1 square minus b gihapon omega 2 square because that's phi that square. Phi that square sine square of theta. Sine square of theta. Theta is equal to omega 1 t. So this is in the radial direction. Minus b omega 1 sine square theta. Okay. Okay. ER minus for E theta. Sa E theta is isa lang ka-term or duha. Duha ni ka-term. Sa E theta. Yeah. This one is also 0. The R dot is also equal to 0. This one is also equal to 0. Okay? So, ang mabilin is isa lang ka-term for E theta. And nako isa ka-term for E phi. Okay? So, we have minus B. Phi dot is omega square, omega 2 square. Sine of theta, sine of theta is omega 1 t. Cosine of omega 1 t e theta plus kato na bilin sa e phi which is equal to 2r. R is b omega 1 omega 2 cosine of omega 1 t e phi. So this is basically the acceleration of that wheel. Okay, of that wheel. And ang ipangita, this is the general acceleration, but the problem is actually calculating the acceleration of the highest point on the wheel. Okay, so this is the general expression of our acceleration, but kung ano to ang specific na acceleration at the top, okay, tanang to at the highest point, no? Find the acceleration. Okay, nakuha na to, no? Define the acceleration of any point in the rim, on the rim of the wheel. Okay, so that is kaning akong gibaksan. And then next is, in particular, find the acceleration at the highest point on the wheel. So what do you mean by at the highest point? At the highest point on the wheel, meaning at the highest point, okay, it means that your theta is actually equal to 0. Okay, meaning your omega 1 t is equal to 0. So what will happen? Ang mabilin is only, as you can see here, if your theta is equal to 0, at the highest point man, no? At the highest point, kay naaman diri imong theta, no? Gi-measure man nimo imong theta dari. Gi-measure nimo imong theta diri, no? Diri. So nag-rotate siya padulong dira. At the highest point, meaning na diri imong particle or kaning point imong gipangitaan og acceleration dira. So it means that your theta here, your theta in that point is equal to 0. So what will happen is na ko sin theta, kini siya, the sin omega 1 t is 0 because sin 0 is 0. Also this, it is also equal to 0, and then this one is equal to 1. Sakto? Tama ba? Cosine 0 is 1. So therefore, the acceleration at the highest point is na ko'y minus b. Ito. Minus b omega 1 square. Okay, ma-0 man yun, kaning second na term, er, the radial direction. Wala ko e theta, right? Wala ko e theta nga part because sin omega 1 t is equal to 0. So mag-0 iyahang theta nga direction. Plus na ko 2b omega 1 omega 2 cosine 0 is 1. So therefore, at the highest point, your acceleration is equal to this one. So this will be my acceleration at the highest point of the rim of the wheel. Okay? So the general expression is this, kani sa taas nga box, the particular solution for acceleration at the highest point is given by this. Okay, and if you graph this, okay, graph na ko ni, in terms of omega 1, this is parabolic. Parabolic iyang form or what? Parabolic ba ni? I don't know. Tingnan natin yung graph na lang. Okay, so that's it. As long as you know, once again, as long as you know the r, the function r, the function theta, and the function phi, you can actually solve for the velocity for the acceleration of the given system in spherical coordinates. Simple, okay? Simple lang, no? Now, let's now go to cylindrical. Okay? Cylindrical coordinates. So, sa spherical, ang gagamit ng coordinates is r, theta, and phi. But for cylindrical, ang atong gagamit nga functions or variable is na kay r, phi, and z. Okay? R, phi, and z. So, nga ng cylindrical, no? If you draw the na yung mga system nga sayon na sa solve ng cylindrical coordinates, na po yung mga system nga sayon na sa solve ng spherical coordinates. Okay? Ano ito? Ano yung cylindrical? This is spherical. Ito cylindrical. Okay. This is cylindrical. Oh, wait. The coordinates are r, phi, and z. Okay? So, okay. So if this is my point here, kung lang taon mo lahi siya sa spherical, no? If this is my point, nga kuhaan nimo og say position vector or what, okay? This is my point here. The r, take note, is not the vector from the origin to that point. Okay? Take note si r kay dili siya ang vector nga ga-start sa origin padulong sa point, tama? Sa spherical kay mo na itong r, no? Ang spherical kay mo na to ang r. But in cylindrical, your r is actually this one. Projection lang siya, no? From the origin to the point nga gi-project nimo siya in xy plane. Okay? Gitawag siya nga cylindrical because ang iyang forma is this. Nakoy, ingani sa forma, no? Mag-draw ka og cylindrical nga cylinder, okay? Naka-cylinder. Si R is actually si R, okay? Si R is actually the radius of the cylinder. Okay, so mura na ang kalayaan. If this is my point here, kung diri ka makuha og position, for example, si R is not the vector from the origin to that point, but R is just the radius of the cylinder. So diri ra nimo kuha ng R, okay? Diri nimo kuha si R. Always mura siya og radius lang sa imong cylinder. That's your R. Phi, wala nag-change sa phi. Si phi is just the angle from the x-axis padulong sa mulibot sa kaysa. Okay? Mo rotate sa kaysa. So that's your phi. But the z, si z is the height of your point from the xy plane. So muna akong z na karon. So muna si r. Muna si r, no? Muna si r. Si z is ang height ni point P from the xy plane. So that's for cylindrical coordinates. R nga dako ilang gamit. Sige lang. R nga gamay or R nga dako same na sila, no? Sige, R na lang nga dako akong gamit para kaysa libro they used R nga capital letter R. Okay? So we have capital letter R, phi, and Z. Si R nga capital is katong sa ito, the radius of the cylinder, okay, nga ma-create sa imong point, okay? Nga ma-create sa imong point, the radius of the cylinder. Phi is just an angle, the range of phi is from 0 to 2 pi, 0 to 360. And your z is actually the height of your point from the origin, from the xy plane. Okay, so that's in cylindrical coordinates. R is also, as you can see here, the vector R, okay? Muna akong R, no? Muna akong R in cylindrical. The vector R, if you say position vector R, if this is my point P, the position vector R is kani, no? Muna ako in spherical, muna akong R. Tama ba? Muna akong position vector R. Take note, si R nga dako is katong radius sa imong cylinder. Okay? And as you can see here, using vector analysis, you can solve for R from here. Tama ba? Kung lang taon mo, this is a right triangle. If you draw this one, if you draw the relationship between vector R and the capital letter R and Z, nakoy makuha nga no? Nakoy R. Okay? This is my position vector R. This is my R, cylindrical coordinates R, and then this is my cylindrical coordinate Z. Sakto ba? So as you can see here, this is actually you can actually write position vector R in terms of capital letter R and the variable Z. From here, the position from here vector R is equal to this. Pila gani? Nakoy R going to the ER plus Z going to the unit vector EZ. Sakto? Take note, the unit vectors are these. Nakoy ER, tapos nakoy E phi, and then nakoy EZ. Okay? So, your position vector R is given by this equation. Sakto? Tama? Based from the triangle nga nasa taas, using vector analysis, that is actually equal to this one. R times the unit vector ER plus the vector Z, which is equal to Z, distance Z times the vector unit vector EZ. So once we have the position, we know the velocity. Velocity is just the derivative of R with respect to time. So this is equal to R ER plus Z EZ. So pila ni? Nakoy upat ka terms, tama? So nakoy upat ka terms ani, I have R dot ER plus R ER dot plus Z dot EZ plus Z EZ dot. EZ dot. Okay. But we know that the ER dot, which is I think nakuha natin ni siya sa katong plane polar. Okay? ER dot is actually equal to phi dot E theta, E phi, sorry, wala E theta rin sa cylindrical. ER dot is phi dot E phi. EZ is equal to 0. EZ dot is equal to 0 because murag yapon siya o gatong Z unit vector Z in terms in Z axis. And take note, it is constant with respect to time. Tama ba? Katong E1 dot, E2 dot, E3 dot are equal to 0. Okay? E1, E2, E3 dot is equal to 0. The EZ dot is just the E3 dot. Okay? The EZ dot is just the unit vector E3 dot. So 0, it does not change with respect to time. So dili mag-change yung direction. So therefore mag-0 ni siya. So therefore kaning last term nako, kaning last term will be equal to 0. So therefore the velocity is equal to, in cylindrical coordinates, take note na ko R dot ER plus R phi dot E phi plus Z dot EZ. So this will be the velocity of the object in cylindrical coordinates. Okay, R dot ER, R phi dot plus Z dot EZ. Sa acceleration, dali lang, no? Acceleration, you just have to derive the V. Acceleration is you just have to derive the V. So we have Pila kay to ka terms ang v ganin ako'y upat lang no tulor di ay tulor ka terms na ako'y r dot er plus sorry r phi dot e phi plus r phi dot e phi z dot e z. So if we derive this, I have 6 terms. Ako'y r double dot er plus r dot er dot plus 7 terms din no nakoy r dot phi dot e phi plus r phi double dot e phi plus r phi dot e phi dot plus z double dot ez plus z dot ez dot. But take note, ez dot is 0. Kani siya kay 0. Okay? So it has 1, 2, 3, 4, 5, 6 terms. So na ako'y 6 terms and you can actually write this the er dot, okay, the er dot is equal to er dot is equal to e phi theta theta dot not theta phi dot. Okay, so you can reduce this into this expression here, r double dot minus r phi dot square er plus 2 r dot phi dot plus r double dot phi e phi plus the last one is now z double dot e z. So this will be the acceleration of the object in spherical coordinates. R double dot minus r phi square. Okay. Okay. So this will be the answer. 2 e phi r phi. Okay, sakto because this one I know ano to. Anyways, this one is this er dot is phi dot e phi i-add lang nimo sa kani so that's one ako itudra. Okay, the minus r phi square is actually this one kani e phi nimo, kani e phi dot nimo is actually minus phi er. Okay, this one, the e phi dot is equal to minus phi er. Okay, minus phi dot er. So this will be the acceleration in spherical coordinates. Nga lang, no? So kabalo ta, what are the accelerations, what are the velocities in Cartesian coordinates, plane polar. If you generalize the plane polar, you have the spherical coordinates. And the last one is cylindrical coordinates. So na depende lang dayon sa problem. Lantawan mo sa problem, no? Lantawan mo ang problem kung unsay mas fit sa iyang gamiton. Pag lantawan mo na kay z function, na kay phi function, then you can use cylindrical. Pag lantawan mo is na kay theta and phi, then you can use spherical coordinates. Kung maglantaw kang XYZ lang, E1, E2, E3 lang, then you can use Cartesian coordinates ng mga function, mga acceleration and velocity. So kana lang gali ra siya, no? Mag-akit tong sayo pa ni gali kato equation to nga sayo pa ni kanino? Kini may sayap, no? Kini may sayap. 1.12.11. So kung makontak niyo si Fowles, pwede niyo sa ano? Pwede niyo siya i-emailan, no? Emailan niyo nga sayap imong answer. Imong 1.12.11. Anyways, okay. So, last example, then we will go. And then next meeting, proceed na ta sa chapter 2. Okay? So, paano tadaan og exam, no? Okay ra? So, our first long exam will be on Monday next week. Okay? Same time, 8 to 9 a.m. And take note ha, live quiz ta, no? Mag-live quiz ta. Okay? Mag-live quiz ta sa live quiz bitaw na. Yeah, live exam. 1 hour lang, good for 1 hour. So, expect tag mga isa o duha ka problem lang for hour long exam. Or na may klase after ani? Ay, na may klase, tama. So, 1 hour na kita dapat. Sige. So, example for cylindrical, we have this, a bead slides on wire bent into the form of a helix. Helix kay, sa forma sa helix gani, katuan na, no? Sorry. Oh, wait. Ano ito akong mouse? So, okay, so for example, a bead slides on a wire bent in the form of a helix. So, ang forma sa imong wire is ngani? Pataas na lang. Saka na lang para makita na to nga cylindrical gid siya, no? Ni gamay ano siya. Okay. So, ang forma niya is pana. Okay? So, as you can see here, the R is not is fixed or is constant, okay? So, ang R is just the radius of this helix, okay? So, R is constant. The radius of this helix is B, okay? Na ako'y given nga R equals B. But night times nga dili constant ang R. For example, a helix siya, pero spiral siya, no? Spiral yung form, ana ang tutsa nagagamay. Okay, so that spiral, it means that your R here is not constant. It is a function of time, and it is reducing as a function of time. So magkagamay siya from time to time. So more siya og funnel, no? Ang motion sa imong motion sa particle is patuyok siya hangtod sa pagamay hangtod sa mustap sa ato. But in this case, in this example, fix lang imong R. Okay? So from time to time, ang imong R is constant lang. And that constant is equal to B. So, dili siya magkagamay, no? Constant lang yung R. So, ingana siya forma, the motion of the bead being given in the cylindrical coordinates, which is R is equal to B, which is constant. R is equal to B, which is constant. Phi is just omega t, no? Omega t, kaning iyahang angular speed is omega. And Z is equal to ZT, no? Z is equal to ZT. Okay. Pataas din siya, no? Okay, this is positive. If your C is positive, if your constancy is positive, then the motion is going upward. Okay, paano sa ito? If it is negative, kung ang C mo is negative, then the motion is going downward. Okay, ingana lang, no? R is equal to B, fix mo hang helical nga helical nga kwan, imong R. And then omega is just katong unsa ka paspas imong tuyok. Okay? The phi is katong angle sa depende sa kapaspason sa iyang tuyok, and the z is depende sa c. If c is positive, it's going upward. If c is negative, it's going downward. So kanila atong timana, no? Kanilang tulo. Question is find the velocity and acceleration of as a function of time. This is very simple because r dot is equal to r double dot, which is equal to 0. Omega dot is equal to omega, while so phi dot is omega, while phi double dot is equal to 0. Z dot is equal to c, while z double dot is equal to 0. So the velocity is just this. V is equal to r dot er, okay, plus r phi dot e phi plus z dot ez. So this is actually equal to answer. R dot is 0. Okay. So nakoy R is B, so nakoy B omega E phi plus z dot, which is c ez. So this is my velocity. For acceleration is, check down for mass acceleration. Diretso na lang. Dali lang. Naman dali, no? Acceleration is equal to minus b omega square er. Ano gali? Kay kani for acceleration r double dot kay ma 0. Okay. R double dot minus r phi dot square er plus 2 r dot phi plus r phi double dot e phi plus z double dot e z, and lagay mag 0 ano, no? Kani 0. Kani pod r dot is also equal to 0. This one is also 0. R double dot is also 0. So ang mabiling na acceleration na lang is this one. Acceleration is na ko yung minus r is b, omega phi dot square is omega square er. So this will be the acceleration of the object which is moving in the helical motion, minus b omega square er. Okay, and that's for the cylindrical coordinates. Kato lang, no? Kato lang. Sayo na kayo siya, no? Sayo na kayo. So, next meeting, we will go now to chapter 2, Newtonian mechanics. Before we proceed to katong force, doon na tayo tulo ka function sa force. Force as a function of position, x, force as a function of time, and force as a function of velocity. We will first review the dynamics of motion sa inyong Physics 41. I-review na to kung kabalo ba ta mo solve aning mga inclined plane, kabalo ba ta mo solve aning pendulum, kabalo ba ta mo solve aning mga statics of rigid bodies, and also the dynamics of rigid bodies. Okay? Kabalo ba ta mo gamit og first law, second law, og third law of motion. So i-review na to gamay to before we proceed to this fx, fv, and ft, no? So mo man ang pinaka pointer, no? What if your f is a function of x? What if your f is a function of time? What if your f is a function of v? This is for chapter 2 nga. But before that, again, we will review some problems in the dynamics of motion. How to use the law of inertia, how to use the law of acceleration, the law of reaction force, and so on. Which will be next. We will discuss that next meeting. Okay, question.
Excuse, sir.
Yes.
Kung ano, sir, kanang pag-quiz na to, sir, ang chapter 1 ra, sir.
Yeah. Tama
magkuha-
na sa itong cylindrical.
Kuha ra may acceleration of velocity ana, sir.
Basta sa tanan nga ito na-discuss. Sa chapter
Okay.
1.
Okay, salamat. Wait, sir,
Sige,
sir.
wala na?
Sir,
Yes.
open notes na siya, sir? Ang
Yeah,
quiz.
open notes siya. Pero live quiz siya, no? Makita na ko nga open cam. So open ang inyong camera. So makita na ko kung open notes siya, pero wala siya kanang open friends or what. Dili siya open friends de, sorry.
Okay, sir,
Open
okay, sir.
Dili siya open classmates de. Sila makita ang po na ko kung nag-solve ba mo or wala, or nanguan ba mo or wala. Open notes siya, no? Open notes, open internet, open Google, pero di siya open classmates. Sana lang. Yeah, open cam siya, Joven.
Maka-google man ka, sir. I-sure na mo ng Google, sir. Ay, friends
Ay,
kami na.
pwede ka mga-Google. Langan ako nasa sa Google, no? Pero,
Sir,
pwede ka mga-Google, but dili gid ka pwede maka-open classmates. Yes?
wala kamera ang PC, sir.
Wala kay camera?
Wala pa, sir.
Naka cellphone. Para pwede duhay mong gamiton.
Sige, sir.
Cellphone ang cam, tapos pwede ka mo gamit og imong laptop or imong PC. Pwede ra na nga na.
Sige, sir.
I-upload din mo yung video, sir.
Yeah, i-upload na ko akong video. Monday pa na exam, no? Sige lang, basta ma-upload na ako karong Thursday. I-download pa mo na ako sa kuan, katong tanan na to sa Gmail. Sige lang. Basta ma-download na ako karon. I-remind lang po
Sir.
ko kuan Jessa ha. Paki-remind ko Jessa.
Sige, sir.
I-upload ako sa YouTube. Sige. Wala na. So see you on Friday and take note sa Monday, may exam na sa Monday. 8 to 9 a.m. lang. Isa lang ka oras. Okay. Okay. Sige, bye-bye. Bye-bye na. Okay. Wala absent gyapon na, wala absent. September 8. Wala absent. September 8.